Hello students. So today's question here says, figure shows a small block of mass m kept at the left end of a larger block of mass capital M and length capital L. The system can slide on a horizontal road. The system is started towards right with an initial velocity v. The friction coefficient between the road and the bigger block is mu, and that between the blocks is mu by 2. Find the time elapsed before the smaller block separates from the bigger block. The figure is shown here. We have this small block m and a bigger block m kept one over the other. There is friction between both the surfaces, set of surfaces between small m and capital M and between capital M and the ground. And what you do now is you provide an initial velocity to both the blocks. So let's first try and understand what really is happening. See that as the blocks move towards right under the effect of this initial velocity, friction will act between both the pair of surfaces that we are getting here. Capital M will experience force, backward force, frictional force from the ground. So it will tend to slow down, yes, under the effect of that friction. The smaller block is also experiencing a backward force of friction from capital M. But see that since the coefficient of friction is different, the amount of friction and hence the acceleration that small m will experience will be slightly less, because frictional coefficient is less. We can assume that the amount of acceleration, backward acceleration that small m will experience will be lesser than what capital M will experience. So what really will happen here is, as the two blocks move, capital M experiences a greater retardation than small m. Small m will slow down slower than capital M. And the net result of this would be that there will be a relative slipping of small m on capital M in the forward direction, because capital M is slowing down faster than small m. As seen by someone who might be standing on, let's say, capital M, small m will be moving forward, in the forward direction on capital M then, and there would come a time when small m will be able to complete the whole length, cover the whole length of capital M and will fall down on the front edge. So we are supposed to find out this time that small m takes to cover the length L over capital M. So first we can proceed with this question by first finding out the frictional forces acting between both the blocks and finding out their accelerations, and see that after that we can work in the frame of capital M. We can assume that, let's say, capital M is at rest. No, this will happen if someone just stands and looks at capital M moving on small m. So if we observe it from the frame of capital M, we can say that small m has to just cover a length of L over capital M and the job will be done. Yes. So in this case, we first find out the frictional force on both the blocks, which we have done on the figure on the right side. So see that there is this kinetic friction acting on small m, which is equal to mu n across small m, which here in this case comes out to be mu by 2 into small m times g. Whereas the frictional force acting on capital M from the ground will be mu into n, which will be mu into m plus m times g. Understand that the normal reaction that capital M experiences from the ground will be corresponding to both the masses small m plus capital M times g. So this is the normal reaction that we are supposed to use. So understand that on capital M there is this reaction force also coming from small m, the same kinetic friction that capital M exerts on small m will exert it back on capital M. So once we know both the forces, we can find out their accelerations. So for block small m, let's say the acceleration is a dash and it will come out to be mu g by 2. Whereas for capital M, when we try to find out the acceleration, we have to take the net backward force divided by the mass, which comes out to be having this value. Now, when we try to work in the frame of capital M, that means we assume that capital M is at rest, we can find out all the terms for small m relative to capital M. So we first find out the acceleration of small m with respect to capital M, which by definition will be a dash minus a, acceleration of small m minus acceleration of capital M, which we can easily calculate now. We have all the values, and we see that this acceleration comes out with a minus sign. Now, why is it coming with a minus sign? We have assumed that not assumed really, we have obtained this, that A dash and A both are towards left. See the upper figure? Both A dash and A will be towards left because the net forces acting on both the blocks are towards left. So, when we try to find out the relative acceleration and we wrote it as A dash minus A, this acceleration that we will get will be towards left only, because both the quantities are acting towards left and we have taken them with a positive sign. When we get the final answer with a minus sign, this basically means that the actual acceleration of small m with respect to capital M is in the direction opposite to what we have taken. So, the negative acceleration towards left we can write as a positive acceleration towards right, which basically tells us that small m accelerates towards right if we assume capital M at rest, which is what we have discussed above also, that small m will move forward on capital M, right. Also, the relative initial velocity of small m with respect to capital M will be, okay, I am sorry, I have made a mistake here. This is v minus v. Both of them have been given an initial velocity of v. So, the initial relative velocity will be 0. V minus v will be 0. And the displacement that small m is supposed to have with respect to capital M is L, the length of the block. This is the displacement that we want small m to have, and we want to find out the time corresponding to that. So, this displacement is L. Because now we are considering capital M to be at rest, we can just use all these values in the equation of motion. The second equation of motion, S is equal to ut plus half at squared in the frame of capital M, and find out the value of t. Do you see that we can connect A, U, S and T using the second equation? So, we just use that here now. We have the displacement L, initial velocity being 0, relative velocity is 0. So, the first term will go to 0 plus half A t squared, and you just solve this equation to get your final answer for the time. Thank you.